In this video, we'll be looking at a problem based on arithmetic numbers. There are a certain number of sweets in a packet. When the sweets are distributed equally amongst 5 children, there is a remainder of 4 sweets. However, when the same number of sweets is divided amongst 37 children, there is a remainder of 2 sweets. Find out the total number of sweets in the packet. Okay, so let's have the number of sweets in the packet as x. Let the number of sweets be x. Now, there are two conditions or two cases rather. When the sweets are distributed amongst 5 children, there's a remainder of 4 sweets. So 5 children, each one of them gets an equal amount of y, and there will be a remainder of 4 sweets. Likewise, when the same number of sweets is distributed amongst 37 children, there's a remainder of 2 sweets. Now some people might be wondering, why can't we just equate both of these equations? Because we have done that in other questions and both of them are equal to x, so we'll be able to find out y if we equate them. Now why we can't do that is because this y is not the same as this. These two variables are not the same. Because the number of sweets when divided by 5 children, the number of sweets that each child gets, the value of y, won't be the same as this variable. Because in this case, the number of sweets is divided by 37 children. So we can have this as y1 and y2. So we have 3 variables totally. We have x, y1 and y2. Since we have 3 unknown variables and only 2 equations, we cannot solve both of these equations to find out the unknown variables. So we can't do it by this way. Let's look at the question closely. The sweets are distributed equally amongst 5 children and there's a remainder of 4 sweets. So we have to find a number that when divided by 5 gives us a remainder of 4. We have to find the range of numbers. Now, I forgot to mention one aspect of this problem. The range is the total number of, the maximum number of sweets in the packet will be 100. So it's not more than 100. Okay, so now this number when divided by 5 has to give us a remainder of 4. So what type of number will this be? Okay, you have to realize that any number that ends with either 4 or 9, the ending digit has to be 4 or 9, any such number will give us a remainder of 4 when we divide it by 5. I'll write it down. Any number ending with 4 or 9 has a remainder of 4 when it's divided by 5. You can try out examples of numbers to verify if this is true. For example, let's take 39. It ends with 9, right? Now if you divide it by 5, it gives us a remainder of 4. Why? Because until 35, it will be divisible by 5. It will give us a quotient of 7 and the rest of it will be taken as remainder 4. Let's take something that ends with 4. Let's take 44. 44 when divided by 5, it will be divisible until 40, giving us a quotient of 8, and then there's a remainder of 4. Even 4, let's take 14. 14 divided by 5, it will be divisible until 10, so it gives us a quotient of 2 and remainder of 4. Now why is this actually? How is this true? Because any number that's a multiple of 5 ends with 0 or 5. So if it's a multiple of 5, or if in other words, if it's actually divisible by 5, it will definitely end with 0 or 5. So I can have 30, 35, both of these end with 0 and 5, and both of these are multiples of 5. Now if there has to be a remainder of 4, then it has to be 0 plus 4. Likewise, if there has to be a remainder of 4 in this case, the total must be 4 more, giving us the end digit as 9. In this case it will be from 0 to 4. Okay, so I hope you understood this part. This is the main part. So now it's very easy for us to list out all the numbers that end with 4 or 9. We have a limit. It has to be from 0 to 100. So it will start with 4 because it's possible for 4 when divided by 5 to give us a remainder of 4. The quotient will be 0, but there will still be a remainder of 4. So there's 4 and then there's 9, 14, 19, and the list goes on. Now you don't actually have to list out everything because it's easy for us to recall any number within 100 that has a end digit of 4 or 9. So I'll just be writing it down. We have 89, 94 and 99. Now let's look at the second condition. The second condition is when the same number of sweets is divided amongst 37 children, there's a remainder of 2 sweets. Okay, I'll be erasing all of this. Now this condition is not as restrictive as the first condition. If the number of sweets is divided amongst 37 children, it gives us a remainder of 2 sweets. So 37 some variable plus 2. Now what we'll be doing is, the 37 is a huge number. So we can easily try out the different multiples of 32 and add 2. For example, I'll be taking 32 into 0 plus 2. This gives me 2. 37 into 1 plus 2. This gives me 39. I have an end digit of 9. And any number ending with 4 or 9 has a remainder of 4 when divided by 5. So this number satisfies the first condition. What's the condition? When distributed amongst 5 children, there's a remainder of 4 sweets. So 37 is a possible number. 2 is not, because it does not end with 4 or 9. Let's look at the other options. 37 into 2 plus 2. This gives me 74. So it might satisfy, but there's a remainder of 2. Now you cannot just ignore the remainder of 2 because the question states explicitly that there's a remainder of 2 sweets when you divide it amongst 37 children. So this will give me 76, which does not satisfy the condition. Then if you look at 37 to 3 plus 2, this number would have already exceeded 100 and the limit is within 100. So this is also not favorable. So the possible number of sweets that can be present in the packet will be equal to 39 sweets. So now let's double check. This 39 sweets, when distributed amongst 5 children, is there a remainder of 4 sweets? Yes, it gives us 7 and remainder of 4. Likewise, when it's divided amongst 37 children, there's a remainder of 2 sweets. Because if each child gets 1 sweet, there will be 37 plus a remainder of 2. So the number of sweets in the packet is equal to 39. Thank you.